Hi all, welcome to the second part of the K-means clustering algorithm. In this part of lecture, we will learn how to implement the K-means algorithm using Python. We will work on two examples and learn about K-means. I hope that you have been through the first part of this lecture series. You can go through this lecture multiple times and I highly recommend you to work on the codes at your own using codes explained in this particular example. You can pause the lecture and note down the codes and use them for practical implementation. I am using Jupyter Notebook for this purpose. K-means is unsupervised clustering algorithm and highly efficient when the dataset is unlabeled and we are looking forward to cluster them. It gives insight from the unlabeled dataset. It is widely used in clustering problems where datasets are of medium or large size. Some practical applications of K-means are in area of client segmentation, website visitor surfing, then pattern recognition, various machine learning problems based on feature similarities, etc. We will work on two practical applications in this particular lecture. First, we will generate a random data set and apply K-means algorithm. In second problem, we will use customer segmentation using a data set. So let us start with our first example. Let us talk about our first problem. In this problem, we will generate a data set where data sets will be obtained using random function. First of all, we import all libraries. We import NumPy, sklearn, and matplotlib library. We run %matplotlib inline as we will be plotting the graph inline. Using random.seed function, we will generate dataset. Matplotlib we are using to visualize dataset using graph. We import k-means method from cluster class of sklearn library. MacBlobs method will be used to generate blobs to plot for visual presentation of data. Now let us create dataset. We use numpy's random.seed function. Here we set the seed value as 0 initially. Next step will be generating random clusters of points for this. For this particular thing, we will use makeblobs class. Makeblob class will use random generated dataset as input. However, makeblobs can take multiple number of inputs. Now it's time to generate clusters using k-means on randomly generated dataset. We are working for value of k equal to 4. That means generating 4 clusters. Here we have 3 parameters. First is n samples, which are total number of data points equally divided among clusters. The sample size is 4500. Second parameter is centers. Here we generate 4 centroids having coordinate value 4, 4, -2, -1, 2, -3 and 1, 1 and initialize them. The cluster of data points with sample size of 4500 will be generated randomly around these 4 centroids. Finally, we assign standard deviation value for the cluster as 0.9. Well, here we obtain X array which contain feature matrix of n samples and their feature and Y is response vector for n samples. Now let us plot the cluster for obtained X and Y using the makeblobs function to which we pass 3 parameters. 3 parameters are sample size which is 4500, 4 centroid coordinates and standard deviation for cluster which is 0.9. Using scatterplot, we plot these data points and visualize the cluster form. The data points are displayed as dots. You can change it to any other mark by changing the marker sign. Next step is initialize and setting up K-means cluster algorithm. As we already have random data, we set up the K-means cluster using parameters. First part of this step is initialize the K-means with three parameters, namely init, number of clusters, and n init. The init parameter is actually initializing method of centroid. We will initialize centroid with method kmean plus plus. It selects initial cluster centers for kmean clustering in auto mode so that convergence can be achieved fast. It speeds up the process of convergence. N cluster is number of clusters to form as well as number of centroids to generate. We will generate 4 clusters for this particular problem. Hence, the value of n cluster is 4. In process to obtain convergence, the centroid will move with each iteration. We give n init value as 12 that will run consecutively. So now we initialize the k-means with these three parameters and obtain the output of k underscore mean parameter object. Now, the model is formed. We will fit the model by passing the feature matrix X. The output obtained as a result of fitting the model can be seen here. Number of clusters are 4 and maximum iteration is having default value as 300. So in previous steps, we fit the model passing the feature set X. Next step is to obtain the labels for each point in the model. This we will obtain using k-means attribute. The attribute we will use to obtain these labels will be k-means.label underscore. We will obtain these attributes and store it as k-means labels. We display it and it will show the array of labels which indicate to which cluster the data point of the dataset belongs to. We will also obtain the coordinates of the cluster centers as shown in code line number 9. We call this as centroids of all 4 clusters. This we will obtain using k-means cluster underscore centers underscore and save it as k underscore means underscore cluster underscore centers. Okay, now let us look at the next code part, that is code line number 11 onwards. Hence, a result we converge the cluster and using k-means clustering algorithm and obtain 4 clusters with their centroids. The centroids coordinates are also obtained as result. Finally, let us visualize these 4 clusters and also view the centroids. For this purpose, we have written a code to plot the outcome of the model. As shown the code in line 11, we initialize the plot with specified dimensions which is 6 by 4 inches. Next, as shown in line 12, we are using colors spectral to create color map. It will produce an array of colors based on number of labels available. We use set k-means underscore labels function as shown in line 12 to get the unique labels. Now let us create a plot using add underscore subplot function as shown in line 13. Next step is plotting data points and centroid using for loop. Since there are 4 clusters, the value of k will be from 0 to 3 as shown in line number 14. It will execute the loop 4 times and create a list of all data points that belongs to specific cluster. It will label it as true if the data points belongs to specific cluster for each iteration. Otherwise, it will label as false. Hence, the data point wise list will be generated for each cluster as shown in line 15, which is part of the loop. As you can see in line 16, we define the centroid, which is center of the individual clusters. Finally, we will plot the data points with color having values in variable call as shown in line 17, and also plots the centroid with specified color which will have darker outline as shown in line 18. Finally, we will plot it by setting its title as Kmeans as shown in line 19. We will also remove x and y axis ticks by using set x ticks and set ticks functions as shown in line 20 and 21. Using show function as shown in line number 22, we will finally display the plot. The plot output you can view here. So in this particular example, we generated four different clusters, and for generating these clusters, we generated random values, and using various functions, we generated the cluster, and we display the cluster in form of scatter plot, and we plotted them, and we can see this. In coming lecture, in the next part, we will go through the second example. The second example is basically related with a real data set, and in this particular data set we will have we are going to use a data set of size about 34,000 records, and it will contain attribute like customer information, like age, total years of employed, income, etc., and we will work and generate cluster. So this is our first example. I hope that you understand the concept. Please go ahead. Please repeat the lecture again and again. Go through the code, execute it your own, and I hope that you had a good learning. Thank you very much for being with me for this particular lecture. We'll meet in the next part, that is lecture number 3 of Kmeans cluster. Have a good day. Learn, share, and grow. Thank you.